This call is now being recorded.
Do you know
Yes.
Hindi?
Yes, I do.
Okay, no issue. So, in your syllabus, I can see there are two types of searching. One is sequential and another is binary. Another name for sequential is linear search. Okay, and
Yes.
then second one is binary search. So what we will be doing today, we will be trying to do some numericals from binary sequential search, and we will be developing the Python program. So have you done this program before, sequential search?
Yeah.
Okay, let's see. So suppose you got an array, of 2, 7, 5, 21, 8. No. So what can be the size of this array? Can you tell me?
It would be 6.
Okay, great. So let me name this array as test list. If I apply a function of Python as length, I will be getting the length of the array, okay, as 6. So what we have to do, if we want to find any value, suppose I want to find 21. So I would be starting from index 0. I will start searching from index 0 to index 1. Then I will go to index 2, and I will go to index 3. If I found the value of index 3, then my target is completed, my search operation is completed. Okay. If I could not able to find 21, suppose the value is 99, and I am keep on searching, and or at index 1 I could not get. Again I am searching at index 5. I'm not able to find the value which I want to find, 99. I'm not getting on my throughout the array list. So the 99 value doesn't exist. So it is not found. Okay, not found. And previously 21 was found. So these are the two possibilities may occur while searching an element over a list. So how we search? We search sequentially. We search from index 0 to 1, index 1 to 2, index 2 to 3, 3 to 4, 4 to 5. The way of searching is just line by line. That's why it is also called as linear search. Line, linear search, or sequential search. Okay. So
Yes.
what I am going to do, I am going to create a list here. In Python, we know that we can create list. So let that name of the list be test list, and then I'm putting up the value of this here, 0, 1, sorry, not 0, 1, 2, 7, 5, 21, 8, and 9. So these are my few random values in the list, and I will be creating a function to in order to perform this operation what I have done here, which I have shown you through the graphical. Okay, the same operation I am going to do through a program. So let's see how can you if you I will say to you how you can do it just roughly.
Maybe like a for loop that
Okay,
runs through the each elements in the list, and
okay,
then that for loop would check if
okay,
the if it's equal to the number that's we're looking for.
okay. Good, good, great attempt. In the similar way, we can go. what you said is correct, but we need to just make it more vivid through a program. So let's see how can do that. We have already created a list here. Okay, and we will be calling a function. Okay, so we will be calling a function, and for that I need to create a function. Suppose I have got a print statement here, and within the print statement I am passing something. So I need to pass something which will call this operation which I have performed here, along with what I have to search. So suppose I'm giving here ordered sequential search. This will be the name of my function, and I will be passing this list into the function from here, and I will be also passing the value which I want to find, this 21. Okay, so let me pass this value. So what I have done, I have called this function. Let's make it very simple here. Sequential search. Okay, so as of now I have not created this function, right? So I need to create this function. So how do we create a function? What is the keyword used to create the function?
The def, def.
Exact. Very good. Def and the name of the function which I have called below, sequential search. Okay, as again I'm passing two parameters here. One is the list, one is the value which I want to find. Okay, so what I'm going to take, I'm going to collect those. These are known as uh, argument. From here I'm passing an argument, and this argument, when it is sent to the function, it is called as parameter. So you can change the name of the parameter as a list. This thing and this thing is same. Okay, so here I will be passing, instead of this number, I would be taking up inside a variable, and a variable can be anything which you wish. I am putting up, giving it name as item. So here it is. So if you see this thing, test list is actually now the name has changed to a list. And this two name can be any name, whichever word, English word you want to use for it. Again, here I have passed a number, and here I have collected that number into a variable item. Clear so far?
Yes.
Any doubt?
So far it makes sense.
Okay, great. Since in Python we need to take care of indentation, so what I am going to put, I am taking up some kind of this line here to indicate I have given indentation. So in order to handle my index value, these things, these all things, I'm taking a new variable called as pos. Pos here means position. Pos here it is for position, or you can say index of an array. Okay, initially I'm assigning a value 0 to it, and I'm also taking another variable known as found. This one, I'm telling my computer that I have not found anything, so I'm giving it a boolean value, that is false. Okay, and I'm also going to take one more variable, stop. This will be also false. Okay, as you said, we need to take a loop, because we will be iterating through our index value from index 0 to index 1, index 1 to 2, index 2 to index 3. So instead of for loop, I would prefer going for while loop. Okay. So let us take while loop here. And what I'm going to do within the while loop, I'm going to start my searching operation. So this is the indentation for my while loop. So what I'm going to do, I'm going to start searching from index 0 till the length of my array. Consider I don't know the array size. So I can handle that through, first I will take up the variable position 0 because I'm starting from 0 here. Okay. Should be less than the length of my array, my list. So by this I can get to know, okay, as of you can see the size of the array is what, 6, right? So I can go up to 5 because we have taken less than 6. So initially it will be from 0 to 6 because by this function length I can find the size of the array. Okay. And we
Okay.
have another keyword called and, which I am going to use here. And to make things both the side as true. Suppose and is used is a logical operator. When I want something, the condition from here, this side and this side should also be true. Then only I should enter the while loop. Okay. So what I'm going to put, not found, means I'm putting not value before the found, means it should be true. Found. Found is my variable here. Okay. And one more way I'm going to not stop. It should not stop. Again, it should be and not stop. So here my loop is ending here. So altogether there are 3 expressions we are handling here. So what are those expressions? Let's see. This is the first comparison we can see here. Another not found, matlab this will be true with the opposite of the false, and not stop. There are 3 conditions we are checking before entering our while loop. Got it?
Yes. Okay, so like the position starts at 0, right? Its position is equal to 0.
Mhm.
So how does it know that it's index 0?
Initially, you have mentioned here as position as 0. That is why it will know as position as 0. And it will be comparing with the size of the array. Here in case we have 6. Got it?
Okay.
And this position value will keep on increasing again and again as long as the while loop is running. I'll explain you that in further explanation. Just go. Let's see what is happening with, inside the loop. Okay, let's go ahead. Inside the loop, what we'll check, if my array list, a list position value, suppose this position value is equal to what I want to find, that is this one. That means I have found my value. So I will be I will be assigning found variable, this variable found, from false to true. Okay. Else, if this condition is wrong, then I will be checking again if, I think I'm falling short of space here. Array list position is greater than item. Suppose it is greater than item value. Let me take this down somewhere here. Bear with my handwriting. Okay. So if suppose the position value is not equal to item, if it is equal to, then we have found the value. If not equal to it, either it can be small or it can be big. If it is bigger, then we'll have to stop there itself. We don't need to go ahead, else we'll keep on increasing. Okay, so let's see what does this mean. So, and finally my while loop will be actually going to end here at this line. This will be the last indentation for that, and this will be the indentation for this else statement, and this one, this will be up to this line, and here I will be writing return form, return form. Okay, and let me write those statement again. So what the name I have given, test list equal to sorry, 275 21 8 9, and the next line was, I'm writing here my next line, print the name of the sequential search and test list. I'm passing this variable test list, that is an array list here, and I'm also passing the value I want to find. Okay, let's run the code and see what's going to happen. Okay, so what will happen here, the program, as soon as the program start, the program will keep on reading this line, all just keep on reading this line, and as soon as the control reach here, it will create an array inside my RAM, where inside the RAM this value will be going to be stored. Let this be 28 and 29, 28 and 29. I'm changing the index values here, and this will be my index. Okay, so far clear? Hello.
Yes.
Okay, so I have changed certain values here just to make something more interesting here. So let's see. Okay. See what happened when this line is hit, this function will be called, and the control will directly go to here. And whatever you have passed here in the test list will be assigned to this new variable a list, and whatever you have want to search 21, it is assigned here, right? So here 21 is there, and here the entire my array is there, which are this thing. So now initially the position value is what? Is 0. What I have got found as a value initially as false. My stop is also false. So let's see what happens here. The position value will be 0, which is less than 6, because the size of the array is what? 6. Okay. And it is not found. It is not stop. So I would be going, my all conditions are true here. So I will be going inside my loop. Now at position 0, a list of position at index 0. What I have 2 here. And inside my item, I have passed what? I have passed 21. So here it is 21. Is this both the 0 and, uh, 2 and 21 equal? 2 double equal to 21? Is it equal?
No.
No. That's why we are not going to run this line. We'll be moving into else part. As soon as I entered the else part, I can see again I have an if condition here, and I have to see at position 0, I have a value 2. Is the value greater than the item what I was searching 21 here? Is it greater? Yes or no?
No.
Again, no. So I would be going, again, this line is not going to run. I would be going here. At this point of time, position index value was 0 plus 1. The new value was position will be 1. And I have not completed my loop. Therefore, my loop will run again. Now position value will, as my position value is increased to 0 from 1, 0 to 1. Now I will be here. Got it? How we have changed from 0 to 1.
Yes.
So let me give it all this stuff. So again, since I got position new value pos as 1, it is less than 6. All of the conditions are still true. Then I will be going inside my while loop. Here at position 1, I have a value 7. 7 is double equal to 21. Is it equal?
No.
No. That means I am not going to run this line. I will be moving to else part. Inside else part, I have an if statement here again. At position 1, is 7 greater than 21? Again, no. I won't be running this line. I will be going to else part. Again, my position from 1 plus 1 will become 2. Therefore, while again the loop will run, you will be getting position as 2 value. And here, it is going to remain same. Let me again demo this. See, what I am telling here is what happens inside the RAM. Okay. As a developer, we should know, okay, what is happening inside the coding at every stage of life. So now at position 2, which is already less than 6, I can enter here. Rest of the things are again false, false, false. So again here at position 2, I got 5. Same thing will happen. Okay. Now position will be 3. I'm directly jumping to 2 plus 1 here again 3. So now at position 3, here at this point, which is less than 3. At position 3, what I got, there is 21 is double equal to 21. What I got found as true. I got found as true. Yes.
Yes.
So this condition got true for index 3. So I will be coming out of my while loop and I will be returning my current value of my found. Previously it was false. Now because of this line, my found value have gone to true. Okay. So
Okay.
at this particular place, I would be getting 2 as my final output.
Okay. How about if it's greater than like the second?
Greater than.
Mhm. If a list position is greater than the item stop equals true. That line.
Where you are telling me?
Uh. You have it in the second else. The first else. If a list position is greater than the item, stop equals true.
Okay. The reason behind adding this thing, right? Okay, that you are telling me, right?
Yes.
So suppose at particular position you want to search a value, suppose 99. And here at position, suppose at 3, same place, you got 12, 121, which is actually true. Suppose considering that here it is 121 value, and you was about to find 19. So at position 3, you reach position 3. Let's consider the same thing from here. Consider this as the initial value, and I am searching 99 here. So what happened here? So at position 3, which is less than 6, I reach here. 3 is less than what I got here is 1 to 1, which is 99. It is not equal, right? So again, this line is not going to run. You will reach here again, and again you will reach here. At this position 3, your value is 121, and the item you want to search was 99, and this number is greater than 99. And since this is greater than 99, that means I cannot move ahead. Is no need to find further. No need to find further. Why this line I have put? Because in that case, this searching was done on ordered list. This is considered to be an ordered list. That is the reason it is not a random values. It is an ordered list here. Suppose it's 128, 129. So,
Oh,
so here it is 121, and you want to search 99. So it is useless to search further, right? So it is no,
yes.
it doesn't make any sense to search here and here because you already got the value which is bigger than what you are searching. So it's
Okay.
useless to go ahead searching that. That is the
Mm.
reason. So this program is actually going to work when you have an ordered list. That is the reason I mentioned when I was writing it, ordered sequential search. Previously, at the very beginning, I was about to write that. So this code is going to run on ordered sequential search. When you have input values, but all the values as uh, in an ordered list, means it already sorted. Okay.
Okay, makes sense.
Okay. So this is how the program is going to be, and we have already seen the numerical. And on a similar way, you can develop an algorithm for this thing for ordered list. What happened in this case? Let me take the input again. 27512 275. What was that one? 21, 20, 29, right? Okay, whatever it be. This is an entire array list. If you are able to find your value at very first position, suppose you want to search 2 and you got the value at first index itself, that it was very lucky enough to get that, right? So this is considered to be a best case. Best case where your big O notation of best case will be 1. Means you have got the your target value, what who you wanted to search at index 0. Okay. Suppose after searching for the long time, you wasn't able to get to the entire array, but unfortunately, the target you was searching is at the last position. Means you were searching 99, and your target value which was you was searching is at the last position. So that goes to worst case because it is at the end of your array. So what is the size of the array? Here in this case, it is 6. So there can be any numbers inside an array, right? So let us consider to be n number of values. So here the uh, we can give this as a big of 1, big of n. Suppose consider you were searching 5, and after searching from at here you did not get 5, at here you did not get 5, here you got the 5. somewhere in the between. So this comes at your average case. So this is going to be average case, where you can say that it is n by 2. What? How we calculated the big of notation? Understood this?
Okay, so for the average case, since it's like in the middle, you divide it by 2.
Yes.
Okay.
Whatever the size of the array will be. In this case, we have taken 6, right? 6 is the size of the array. There can be 100. There can be 1 million. So if you're able to find your target value somewhere in the between, that will be considered as average case. If you're lucky enough to get the your target value at the very beginning, that will be considered as the best case. And it is unfortunately you're getting at the very last value, then you can say it's a worst case. What?
Okay, yes.
Great. So what we saw in the linear search, when we have limited number of values in an array list, suppose there already we have 6 values, it's very easy to find anything, right? Even if in case there is 100 values, again that is easy for computer to find. But what about if we have more than 1,000 values? So if unfortunately what you want to search is at the position 99th location, index value, these are my index value. You want to search and it is in the very last position. So in order to make it more efficient, the time calculating at worst case, suppose to search an element at location at the last location is taking me 5 seconds to search at here. First I searched here, 1 second was wasted. Again I start searching here, another 1 second was wasted. I start searching for my target value, did not got. Then I did not get another target value. I did not get another target value. And at the worst case, I could able to find my the target value at this particular location, which was my last index value of an array. So that was the case of an average worst case, right? So how many attempts the computer took? And computer took 6 attempts. So it took 6 seconds to solve this. How can I reduce this to at least half of the time? At least half of the time. In order to make our algorithm more efficient, we have another algorithm that is known as binary search. Okay. Getting
Yes.
why we are going for binary search? Because linear search is good when you are having little or small number of values. Suppose around at least 100 values are there. You want to search from 100 values. But what about if you have thousands of values? You want to search from thousands of. Okay. Consider you're searching something on Google. Even if suppose you're searching my name in Google, it's my name in Google. So within 62 seconds, 0.62 seconds, Google is able to find me. Here is me. Okay. So you can find me. How much time it took Google? It took only 0.6. And there is 8 billion human population around that. And among them, I am the one. So similarly, to make the program more efficient, we have more better algorithms available. So here we are going for linear and binary. So how binary work? What happens in binary? Suppose you have the same case, 2, 7, 5, 21, 28, 99. Let's take it as an index value 0, 1, 2, 3, 4, 5. In binary search, the entire array is divided into 2 halves. And the middle value is considered to be your final answer. Middle value is considered to be your target or final answer. Okay. So how this is done? Let's see the numerical to solve this. So what we are going to do is consider the same example: 2, 5, 7, 28, 21, 28, and 99. Okay, suppose you want to search 28 here. So your target item to search is 28. So how many attempt and linear search will take? Let me know. Can you tell me?
How many linear search?
How many attempt or computer time a linear search will take to find 28 in this list?
5.
Exactly. For linear search, it will start searching at index 1, did not get it. 1, 2, 3, 4. So altogether, there will be 5 attempts. Okay, understood?
Yes.
Okay. We want to reduce this to half with binary search. It should at least take 3 or 2 attempts, not more than that. We can achieve that through binary search. Let's see how we can do that. So let me name this position as lowest index, and this position as highest index. What I have done, I have assigned a variable to the lowest index value and a variable to the highest index value. Sorry, this is not the highest index value. Here is the highest index value. So 4 and 5. This is going to be my highest index value. But so here low is equal to 0, high is equal to 5. And I'm going to take another variable called as mid. Middle value is going to be my expected target value, what I want to search. Suppose in case here I want to search 28, 28 is my target value. So I'm expecting the target is my final answer. If I get able to find 28 in my list, then I got the value, found the value. If I'm not able to find 28 in my list, that is that particular value does not exist. Okay. Either there are some other name conventions given in your references. Instead of low, somewhere it is mentioned first and last also. So you can use this variable also. So let me take this only as per your notes. And first is 0, first index value, and the last index value is 5. And we have a middle value, or you can say a midpoint. Okay. So in order to calculate this, what we are going to do, we'll be doing like this: midpoint equal to first plus last divided by 2. So what is the index value of first?
0.
0, exactly. And what is the index value of last?
5.
5 divided by 2. Then what we got? 5 divided by 2 will be 2.5.
2.5.
So we can take either 2 approximately or 3. But I'm not going to go for 3. I would be going for 2. You can go for floor value or ceiling value. You know that flooring value and ceiling value. So if you have 2.5, flooring value will be 2 and ceiling value will be 3. Understood this thing?
Okay.
Reason I'm going to take this because we don't have indexes in point floating numbers. These numbers are floating numbers, right?
Yes.
And these numbers are integer number. If you have studied C programming, so these are whole numbers, integer number, right? So these are my floating number or decimal number, you can say. So I don't have my indexes in decimal or floating number. I have in integer number. That's why I can either go for 2 or 3. So I would be going for approximate value as 2, not 2, 3. Getting it? Why I took 2 here instead of 2.5? I have taken it as approximately 2. So midpoint what I got 2. If my midpoint value, array of mid, consider this array of mid point is double equal to the target what I am searching. My target is 28, right? If it is true, then I have found, and found is equal to true. In this case, is it true?
No,
Why?
because the middle value is 7.
Exactly. Very good. Here is my middle, where it is my midpoint, and it is 7. So I did not get my target value at 7. So it is good to find again here, or it is will be a waste of time finding my value somewhere here. I'm asking you,
Yes.
is it good to find or will be a waste of time to find my target value at this particular region?
Oh, in that location, it would be a waste of time. Yeah.
Exactly. Why it will be a waste of time? I got 7 as my value, which is actually less than my target. That means my target is maybe somewhere around at this place. At this place. So my array is now divided into 2 parts. My entire array, this array is now divided like this into 2 parts. This will be considered as lower bound or lower half. Then and this part will be considered as upper bound or upper half, you can say. So that means I have to find my target value somewhere around at this place. Getting it?
Yes.
So as I have divided this, now I need to check whether my midpoint is midpoint value is less or greater. As I found it is actually less, right? So I had by coding I need to check if my target value, that is again take it as target itself, variable as target, is less than my array of mid value. If target is less than the mid value, then that means I need to change my first from here to here. Okay. So my new array will be this thing. My new array will be this thing. So this will be my first 3 and this will be my last. What?
Yes.
We have divided the array into two halves, and we got to know that the lower bound is useless for me and upper bound is required. So I need to change my variable which was first mentioned here as index 0. I need to change it into first from 0 to first to 3. And how I can do that? As I got the condition here that my target is 28. Oh, sorry, the target is 28, and the value which I got here in 2 is 7. The 28 is less than 7. The condition is false. So I have to go other way around. Here in this case, I need to wait. I think I need to put this like this, as I have explained the other way around. Midpoint is less than target. Okay. So here 7 is less than 28. If 7 is less than 28, then what I have to do, I have to midpoint, whatever the index value of midpoint, add it with 1 and give it to variable first. So my first from here will go to here. How? Midpoint index value is what? Is 2. Add 1 here. 2 plus 1. We got 3. So the first variable is now at the position 3. What? How we came from the first, the value of index value of first from 0 is changed to 3 now. Getting it?
Yes.
Or any confusion?
No.
Suppose, let me change the condition situation here. We got an array again, value 2, 5, 7, 21, 28, 99. Here you have an index value 1, 2. I hope either my alphabets are visible to you. So considering my first equal to 0. Again I am explaining you high as 5. So what I'm going to do, I'm going to write first as 0, high as 5, and mid point we need to calculate that. So mid point equal to first plus high divided by 2. So what I'm going to get here?
0.
0 plus here 5 divided by 2. Again same thing, right? Here I am going to get 5 divided by 2. That will be approximately equal to 2. Okay. So
Yes.
again, what I show you, and suppose the target at this time is your 5, not 90, 28. This time we are finding this thing. Okay. And what did I got? Midpoint as same 2. So this is my 2. So by looking at this situation here, what I got to know that finding my target value from here till here will be a waste of time, right? It's useless to find anything within here because my value is actually less than what I got. Okay, so if the target is less than a mid value, array of mid value, midpoint. The target is 5, midpoint is 7, right? Here I got 7, and I want to search 5. Here it is case. So what I have to do, I have to change my high equal to 5, which is equal to 5 from here. I have to bring it here. Getting Aisha how we are finding this?
Yes. So we're this time the high changes.
Exactly. Previously, what we did, we was finding from here till here on the upper bound, and we changed the first index value from 0 to adding +1 to it at the location 3. We brought it 3 here, right? We brought it to the index 3 by writing this thing, midpoint +1. So in this case, my target value is 5, which is less than the 7, right? So it is useless to find that upper bound. I need to find it somewhere between this. So I would be, what I'm going to do, I will be placing my high, which is 5. I will be putting it here. So how I'm going to reach there, I will be subtracting it. So I will be changing high equal to midpoint -1. Midpoint is what? 2, right? I would be putting it as -1. The 2 minus 1, I'm going to get 1. You will be here, right? So this is how we are going to keep on searching. Understood?
Yes.
Any query here? Any question you have?
No, it makes sense. This time it's going to because it's
What is
going
upper
to
bound, lower bound? You got it, right?
yes.
Okay, let us write the code for this. See, at the end, we will be getting our answer at midpoint only. So let me tell you how. And
Okay, so once you get the upper bound and lower bound, it's going to do the mid again. Would it do the mid again then?
it will keep on finding the middle value. Either it will
Okay.
be at the upper bound, either it will be at, or it will be at the lower bound. But the final answer you will be getting at the midpoint only. Getting it?
Okay. Yes.
So let's start writing the code. I will be creating a function here. So first line depth, I let name it as binary search. We have one critical condition to be seen here is whenever you have an array for binary search, it should be sorted. It should be always sorted. You cannot work on random values. Binary search cannot work on random values. Okay, this is the first condition we should make. Your array should always be in either in ascending order or it should be in descending order. Getting?
Yes.
Okay. So in similar way as before, I will be having a test list here, which will be holding my these values 2, 5, 7, 21, 28, 99. And at print, I will be calling a function called binary search. And here I will be passing a test list, and I will be searching for 5. Let's search for 7 here. Okay, so just like before in the linear search, the similar coding we have done. This part test list will be passed to my these parameters. Okay, here I will be naming it a list, and for 7 I will be naming it as a variable name. Let it be target or it can be item. Okay, I hope it is clear. This time, instead of target, I'm using the word item here. Okay.
Okay.
So let us initialize first as equal to 0, this thing. Let us initialize this thing, but as I don't know what could be the size of an array. Here I can see the size of the array is 6, but it may be a possibility that the number of values inside the list can change at any time. Okay, so what we can do, we can put the variable here last. We'll be going to calculate. Let us calculate through the function length and pass this list to the length. And whatever the function will be putting minus to it, because we actually need this value, not actual size of the array. Here the size of the array I will be getting 5, 6, right? Right. The size of the array will be 6. So I need to subtract it by 1 so that I can get my 5 here. Understood? Yes. No.
Oh, okay.
What in the why do we add this line? Okay. If you found or if you not found, if you found, initially will tell it on my computer that I did not find anything. So found is false. Found is false. Okay. So since I need to iterate my thing again and again, so what I have done here, 0 last is equal. Okay, what I have to do, I have to iterate over my means this is my array. I have to divide it into the half. Either I can find my value somewhere in the lower bound, or I would be finding my value somewhere between here, right? If I got this, suppose consider I could able to find my value somewhere here. So I need to again divide this into half. Maybe I would be getting my value in this lower bound, or maybe I would be getting my value at the upper bound. Suppose this time I'm getting at the upper bound. I need to again this divide again into a half, and maybe at this middle point is my final answer. Getting how binary search works? Just a graphical idea I have given here. Consider
Yes.
this entire rectangle as your array. Okay. So this thing which I have done here, entire array dividing into the half, considering you want your target value somewhere here. With this array we are taking up again dividing into half, considering your target is value where is here. So this is repeating, right? This keeps on repeating. So we will be handling this kind of iteration with loop, and here we will be having a loop known as while loop. Okay. So in while loop, we will be checking is my first index value, that is 0, is less than equal to my last index value. And I have not got my not found is true. Till now I have not got my value. Okay. So if my 0 is less than equal to last index value is in this case is 5, right? So this condition should be true. If this condition is true, then only I can enter the loop. And this condition is true, means it should be not false, means it should be true. So again, I will be going to the loop. Here, same thing which I have done in the numerical way. Within this, I would be finding my midpoint value, right? Midpoint equal to first. What is the formula which I have used there? Did you remember? First
The
plus
first plus the last.
last divided by 2. Okay, but here in computer, what will happen when you are going to do 0 plus 5 divided by 2? You will be getting what? Divided by 2, right? It is something in elementary school or in pre-primary or primary school. I don't know in what you say in America, in your high school. when you divide something like this. 2 to the 4, right? What you got here, remainder as 1. And the quotient is here. This is your quotient. This is your remainder.
Oh, okay. There's the remainder.
Okay. But if I want to get 0 here, what I'm going to do? In schooling, what we do, we put 0 here, we put 0 here, we put point here, we put 0 here. With 2 5s are 10, here we get 0. Answer I'm getting is what, 2.5. And as I said before, I cannot handle floating values or decimal values. This kind of number are known as float value, right? I cannot handle float value here because midpoint is an index value. I do not have index as 2.5. I have either 2 or 3. It can be 2 or it can be 3. So what operator do I have in Python to get that? Do you remember? Basic.
On the floating division.
Yes. To
Um,
get rid of your this point values. Floor value. You want floor value here. Because I need floor as 2, ceiling as 3, right? I don't want 2.5. I don't want 2.5.
okay.
Just a minute. नई गाड़ी किसी ने नहीं लाया. Okay, sorry for the disturbance.
No problem.
Okay, so I have something called this thing here. 2 times you need to take division operator. This operator is known as floor operator. If you are doing this 5 mod 2, the answer will be 2. If you are doing this 5 divided by 2, you will be getting 2.5. Getting my point here?
Yes.
So this will give you 2.5 when you are using this thing. When you are using this, you will be getting 2. Okay. So for that, I will be taking 2 times division operator. I hope you understand this. Okay. Now, here I am going to get the middleware, means index 2 in this case. Okay. So I need to check whether my index value is my output. So what I'm going to do, I'm going to check if my A list midpoint, index value midpoint, my midpoint is here now, is double equal to 2. Not 2, sorry. This thing, item. Double equal to item. If it is yes, I forgot to put colon. In Python, we need to put colon at every keyword whenever we are using keyword. So if a list midpoint double equal to item, then we can say found equal to true. Okay. So what will happen here is you will be passing this list here to this variable. You will be finding this 7 on this particular list with this particular list, right? So at this point, what is the midpoint we got? We got 2, and at that midpoint is we got 7. 7 is equal to 7. Condition is true, found true. You got the answer true.
Yes.
right? So if you're running this loop again, suppose you're running this loop again, considering you got the answer, so here your index value, in this case, your index value will be, what will be the index value?
Two.
Hmm?
The index value
Yes.
for the found.
No. When you're running this loop again, with considering this is done for you, and you got the answer, that is 7 is double equal to 7. You understand, did you understand how we got 7 out of 7 by 7? Or you're confused here?
Because it, yeah, I understand that part.
Okay, let me read on this. Suppose you're calling this function. This function is going to be here, called here, right? Now your first is 0. The first is 0. The last is value is nothing but 5. You found, you have initialized it to false. Okay, so far it is clear, right? Now
Yes.
the first is 0, last is 5, 0 is less than 5, and it is not found. Not found means it's true that we have not found. So we have entered here. We will be entering here. As soon as we enter here, we got 0 plus 5 divided by 2. Here we got 2. Mid value is 2 to us. And at mid value 2, we got answer 7. At index 2, we got answer 7. And you was searching 7. So you got 7 double equal to 7. And found, you have now changed the found as true, right? Found as true. And as since you have got found as true, then you will be getting in the output as true. Means you have got the answer. You have got the target value 7 in the array. Understood so far?
Okay. Yes.
It
So
was a
and
lucky
also
case.
the reason we put first is less than or equal to last is because we're making sure it's in order.
This first you're telling me.
Yes, like while first is less than or equal to last.
No,
We have that.
we are putting this thing to check whether we are going on a proper order or not. We may arise a case where may happen that your last may become 3 and your first may become 4. So your first number should never be greater than your last number. If it's happened like this, means your loop is over, your array is searching within the array is done, and no need to search further. There is your value does not exist. What?
Oh, okay. Yes.
See, suppose here you got 5, right? Last is 5. Here you have 0. Okay. Suppose we have keep on searching, search. And unfortunately, the last is here and first came here at index 6. So yes, it first became 6. Does 6 exist here?
No.
No. That means we did not find a value, and we have iterated through the entire array, and the while loop is exhausted, and you have break the rule. What you have broke the rule, that your first value is now greater than the last one, and which should not happen. If it does happen, that means your value does not exist inside the array. Okay, got it?
Yes.
Still, can any confusion? Yes, no?
Yes.
Okay, let's go ahead. In this case, we were lucky enough to get the first value as our target value. Okay, the first value itself, we got the value. Suppose we want to find 5, which is at the lower bound. Okay, so what will happen in this case? So here, what I'm going to do, we will be going to else part. We will be going to else part. Here again, you will be finding if your item, whatever you are finding, the target value item is less than a list of midpoint. Okay, then what we have to do in less than wala case? In less than wala case, what we did? Not this. Sorry, I think I changed here somewhere. In less than wala case, suppose your value which you are finding is less than the target value. You are finding 5, okay, and you got 7. If 5 is less than 7,
Yes.
you're finding 5. This is your target, and again midpoint what you got 7, and 5 is less than 7. That means I need to bring this last from here to here. I have to bring last from here to here. Remember lower bound case.
Yes.
So for that, what I have to do, I have to subtract 2 with -1. Okay. So therefore, I'm going to midpoint -1 equal to last. And suppose in case, another case we have here, we want to search 28. The target value is 28. And you got 7. Again, middle value will always be 7 for this array. So you got 7. So for 28 is greater than 7. Yes or no?
Yes.
28 is greater. That means this condition is false. Item is not less than the mid value. That means I need to go to else part. Then I have to put mid +1. I have to put midpoint +1 as first. Okay. Then return from. Let us run this thing and we will be able to understand completely of what is happening into my coding. Okay. Let us see. Just go through the code once.
I can't hear you.
Okay, sorry for the disturbance again. Actually, I have another students here. Here, what we can do here, now here let us run this code. Okay, so when you call this function, again this code is going to run. Okay, so
Yes.
here at a list, you got your list here. Here your 7, here you got your 7 here. But this time I'm not going to find 7. Instead, we will be finding 5. Okay. So again, in this case, let me rewrite this thing so that we can understand it properly again. Yeah. So here I'm putting my, I need to change the color. First will be at first index location, and last will be at my last index location. Okay. First will be holding index value as 0. Last, I don't know what will be. Therefore, we calculate the size of the array 6 and we subtracted it by 1 and we got what? 5. And that is also what we got here, 5. So here it will be 5. Here in found, it will be false. Okay. So we will be entering into the loop. First will be 0. Here will be 5. 0 is less than 5. Condition true. Not found. We did not got the answer till now. So that's why this is also true. Okay. So we will be going inside my while loop. Now 0, 5, 0 plus 5 divided by 2. What we get, we will be getting here index as 2. This thing. Okay.
Yes.
So here is my index 2. At array of list index 2, what we have 7. And the item what I want to search, I have specified it as 5. Okay. So here is my 5. So 7 double equal to 5. Is it true?
No.
No. Therefore, I will not be getting this line. Previously, when we got 7 double equal to 7, at that time it was true. At that time it was
That's true.
true, right? That's why we got the answer as true. But at this point, that was lucky case where we got the first index as the first value. But in this case, we did not get it true. Okay, then it is wrong. So we'll be going to else part. In the else part, what I realized, I was searching for 5. I was searching for 5. Green color is visible. Is
Yes.
this color visible? 5. Okay. I was searching for 5, and at index, sorry, what index we have got here? 2. At index 2, the value is 7. Pi is less than 7. Pi is less than 7 or greater than 7. Which condition is true? Yes,
Yes.
this condition is true, right? So this condition is true. Therefore, I have to, here it was my midpoint here. Since my condition is true, I need to change the variable value of last from 5 to here, last equal to 1. How I'm going to get that? I'm going to get that midpoint value was 2 previously. I will be subtracting it by 1 2 minus 1, I would be getting 1. The index value of last will be 1. Okay. So index value of last will be 1. So this condition was true. Now I would be repeating the loop again because else part is not going to run. Now since else part is not going to run, I will be repeating the loop here. My first is again 0. You can see the first is 0. Last is what? 1. Still with our condition is true and we did not found our value, right? So let me just delete the stuff from here. I hope you are getting what I'm explaining.
Yes, I understand so far.
Okay. So now 0 is less than equal to 1. Means now my first is at the previous position first only. But now in this case, what happened? The last, which was at the last of my array, is now changed to yes because of this last. Okay. So now we came here. As we came here, again this is going to run again. So here 0, here it will be 1, 0 plus 1 divided by 2. What will be I am going to get here? 0 plus 1 divided by 2. What I am going to get? I will be getting actually 0.5. Okay. And approximate value will be what? Approximate value will be your 0 because we are taking floor value. Correct?
Yes.
So midpoint we will be getting this thing. Again, मतलब midpoint is your here. आपका midpoint here right यहाँ पे रहेगा. ठीक है. Then a list midpoint is 0. A list midpoint is 0. At this midpoint, what you have got here is value 2, and you were searching for 5. Again, you did not get the answer. This condition is false. We will be going to else part. Here in the else part, you were searching for 5, and your value is actually 2. At this particular point, 5 is greater than 2. Yes or no? 5 is
Yes.
greater than 2 or less than 2?
5 is greater.
Okay. So 5 is greater than 2. Then this condition is true. So now what will happen? Your first midpoint value, what we got midpoint here is 0. So midpoint is 0 plus 1 means first will become 1. First will become what? 1. So your first will be at this point. First will come here. So your last is also at 1 and first is also at 1. Getting it?
Okay.
Your last is also at 1 now. At this time, your first is also at 1. So it should not happen. It should not overlap. If it is equal, it is okay because we have given here equal to. So the loop will run again. So now your first is 1. Your last is also 1. And which is condition is true again because you have given less than equal to. So what will happen here? Again, in this case, it's quite complicated, getting complicated now. 1 plus 1. 1 plus 1 is 2. And 2 divided by 2, what we get? 1. 2 divided by 2 will be getting 1, right? So midpoint I will be getting 1. Then at midpoint 1, I have the value 5. And finally, I got 5 equal to 5. That is found true.
Oh, okay.
What?
Yes.
So actually what happened here is, in this case, 2, 5, what was that? 7, 21, 28, 29, 12+91. Previously, what happened in this case? First came here. We was having last year. Mid we got here, right? Then we started searching into this array. So first became this, last became this, means 2 and 5. When we start searching for mid, we got mid as this one. The first was also this, and mid was also this. Then later what we did, uh, later last became this, and first also became this. And we calculated this, mid also became this. So then finally we got 5. This is what happened in binary search. So how many attempts it took? If you can see carefully, it took actually 3 attempts. In this case, it took 3 attempts. Okay. So this is how binary search works. Any doubt?
Okay.
So in exam, do you have to write the code or perform the code? What kind? How it is? It is your exams are like subjective or objective type?
There's some coding questions.
Okay, there will be
Also.
some coding question. Okay.
Yes.
And any other about how another question? Other question will be.
I sent you like the example, like something like those, like that format, and some coding questions. Yeah.
Any theory related stuff you have to write? Theory part. It means explanation stuff. You have to explain how the algorithm works.
Yes.
Such question also asks, right?
Yes. Like we had some previously, like output questions too, like scoping and like the time efficiency calculation.
Okay. That is the same thing I explained here. Time efficiency. Best case, worst case, and average case. How much time you will require to calculate your output? In this case, most of the time, whatever the size of the array will be, suppose the size of the array is n, your comparison, your mid value will be always divided by 2. Mid value will be always divided by 2. Means big of notation. Your time efficiency. And it may go further to log of n and till end is to I. If you have a very large value in case. The best case will be this thing, as we in this case we found 7, exactly the middle value. This will be the best case, average case, and worst case.
Okay, so for the binary search, right?
For binary search, yes. I think we have already went to more than 2 hours. Any other question do you have? Is there any other topic you want me to take? Because I think we have very limited time for you. Your exams are approaching.
Yeah, maybe like the
If you
binary search tree, the in order, pre-order, and like that, those topics, and then
In that particular topic, what you want me to cover? You want me to cover numericals to solve numerical, or you want me to do programming in that?
like the overview. We were just like working on the new lecture we had. Okay, I can check the topic.
I think your exam is on 14th December, right?
Yes.
So what I suggest you, instead of going to the entire syllabus, as you have already learned the basic content and basic stuff, so we should not waste time in learning basic thing which we can all easily you can grab it. What I suggest to you is tell me the topic where you are finding difficult, okay, and just mention me the topic on my WhatsApp. That particular topic we will take up in the upcoming sessions.
Okay, yeah, I can send you all the
Okay.
topics.
That would be much easy because we have very limited time. Okay,
Okay.
and since just two searching we took 2 hours,
Yes.
so we do not want to waste most of your time and my time as well. That's why I want we should even our learning should also be efficient, right?
Yeah.
So, as you said, you want me to explain binary search tree. So here in binary search tree, there should be numerical. Is there any numerical problem? Do you understand what is numerical? Or I'm getting it something wrong for you? What
No.
kind of question do you have in such a topic?
So like
If you can share your screen and you can explain it to me if you want.
okay. And can you see my screen?
Yes, yes.
Okay. So we were doing the coding part of the binary search tree.
Can you increase the slide size? It's too
Uh,
shuffle.
like how to assemble the binary search tree, like the order how it goes, and then the
Okay.
in order. I was like a bit confused about the the in order, the pre-order, and
Traversal.
the traversals. I was confused on, and then a little bit about the remove too, like the cases for the removal. And then scoping problems too. I think I got some of those wrong on the previous test. Scoping problems.
What are those? I don't know actually.
I can send it the okay, I send it to you the scoping problem. The local, global, and built-in. Also, for the sorts, I think merge sort I wanted to work on. Merge sort, I was a bit confused on that one.
Merge sort program
Yes.
part.
Yes, the programming part for the merge sort. Also the UML, like how the professor, like I didn't really get it. The UML design.
Okay. How to create UML or fencing? I cannot see UML here. It's constructor and destructor is polymorphism.
Sorry?
It is actually polymorphism part. Operator overloading, object-oriented concept of Python.
Yes.
UML is different thing, right?
I think it was in
Any other slide? The first slide. Show me the first slide. Very first slide.
okay.
No, this is the UML. Third one below the. Okay, just a diagram actually. Unified modeling language. UML is for. We want to understand how UMLs are created.
Yes, like if I was given like a problem, like to make a UML diagram, like this one in the I can send you on the test I did, and I lost some points on that.
Okay. Any other query? Question?
Yeah, maybe like the overloading, operator overloading, like the true div and then IML, I true idiv or something. Yeah, that one. Using like the operator overloading in code. Like the difference between, yeah, there's this IAD, how to implement those, maybe.
Which slide number it is? Lecture number?
Uh, this is lecture 4.
Lecture 4.
Yeah, this palindrome code, how it works. And I also wanted to like get more familiar with this one.
What is that? You cannot see it actually, it's quite small.
Sorry.
Casino 5. Garden deck. Okay, it's quite a big program.
And then the reference versus value.
Yeah, instance as well. How many subjects you have? This
I
semester
have,
is
yeah, 3 subjects.
only 3 subjects for this semester examination.
Yes. Yeah, the time for this, like the operation, the analysis, I was a little confused.
What you said, just show it again.
For this one,
Execution time counting operation. It's again same palindrome. I think it's all about what is okay. Got it.
yeah, the scoping details, this one, lecture 6. There's more scoping problems. Yeah, recursion too. Recursion, I had like, there's like a Catalan program I had to do. I had confusion with that. And then the base conversion for the recursion. No?
Hello.
Yes.
I have a record. I have mentions all of the topic which you have given. It is we can see the my WhatsApp message.
Okay, yes.
I think there are lots of topic mentioned there. It will take lots of time.
Okay, I
Still,
can send you like the main ones.
yes,
Like
yes,
the
yes. That will
yes.
be much better because you have very less time. Right? Even I may not be available Continuous day. Yeah, I would be available for you on alternate days.
Okay, so I'll send like the most
Which you feel the most important for you.
okay. Yes. Okay. Thank you.
Okay, sure. So, do you have an access? You are using iPhone or Android mobile?
Yes.
Which mobile, Android or iPhone?
iPhone.
So, what you do, and download this app, and this app from Play Store. Okay,
Okay.
you're using Android, right? You said iPhone or Android?
iPhone.
iPhone. So, in case of iPhone, download this one. Once and if will ask you the code, then you type this thing NLVTR, and and inside that particular app, I will be updating this video, recorded video, so that you can get an access to the same recorded video through this app. Okay.
Oh, okay. Thank you.
Okay. Last question. So, did you understand what did I explain to you on linear search and manual search? Was it?
Yes.
Did you find it very difficult to you or something? Because it was a demo session for you. Okay.
Yes, it was pretty helpful.
Pretty helpful. That's why. Because I know there is a language barrier again, because your English is different and mine is different. So I don't want you to get confused with my words. So if you feel comfortable, then we can go ahead.
No, it's yeah.
It's okay. Okay, sure. Thank you.